Okay, so welcome everyone to this third group related to the deployment. So today we're gonna go through different options basically that we can use to deploy our application or our model to a production environment using KNIME Server. And before starting, actually, I would kindly ask you to download the exercises if you didn't do that already. And you can actually download the exercises by going to the link that you see here on the slide, this tiny URL. And yeah, what I think it really makes sense to do, at least for this group, is to try to make this interaction, try to make this group like a bit interactive. So if you have questions, we can quickly like discuss about those, maybe also using the chat. And I will start maybe with a short intro to what are the most, let's say, prominent features available with KNIME Server, and then we'll start with the exercises. Okay. Okay, so Paolo quickly mentioned to you already the entire process related to the basically how to handle a data science project. And in KNIME, we identified this graphic that basically shows you how to gather and wrangle data and how to apply and train machine learning models, as well as visualize the results of the analysis that you have performed. And you can actually do this with KNIME Analytics platform. So KNIME Analytics platform is the perfect tool to basically handle these steps on your own, basically, if you're an individual data scientist or data analyst. But then when it comes basically to handle collaboration aspects and also deployment options, different deployment options, as well as manage, for example, like an application or a tool at an enterprise level, then KNIME Server comes in handy. And the idea is that whenever you have your model trained, or maybe you have developed your application and you want to move it into a production environment, you can actually use the KNIME Server, which will add on top of what KNIME Analytics platform already provides, features such as collaboration, automation, management, and deployment. And once you basically are ready to deploy an application and move it into a production environment, you have to keep in mind a number of challenges that you have to overcome and to tackle. First of all, a variety of technologies, because within an enterprise, there are many technologies that have to be integrated between each other. And then, of course, there are different skills and resources available within a company. And there are different requirements. And some of those, of course, come from the data scientist. And results have to be mainstreamed across the entire organization. So you have to make sure that results are not only understandable by the technical team, but they have to be meaningful also for the business for the business people and the business departments. So there has to be sort of collaboration between these different teams, and KNIME Server can actually help with that. We will go through that. And of course, another aspect is also to provide high quality delivery. So this is just a to sum up a bit of like all the different functionality and all the different steps that are involved in a data science project, and where KNIME can actually help in each one of those steps. So first of all, in the gather and wrangle, we have a number of nodes that can help you to connect to databases. You can read data from cloud providers. You can read data from Excel files and CRM systems, etc., etc. You can perform data manipulation. You can do ETL, and then you can also apply machine learning models. And we have here different integrations also to apply deep learning models. And this is available with an integration with TensorFlow and Keras, for example. But of course, if you want to use your model that you have developed, for example, using Python, you can, of course, also integrate with such a tool, with Python, with R. And of course, KNIME also provides a number of machine learning models that with native nodes. So then, basically, as I said, we come to the point where the model that we have trained has to be deployed and has to be available for a production for production. And we knew data coming in from the real world, so we have to really have like an additional environment where we can run our model on top of it. And there are different ways to actually deploy our application or our model. We can deploy it to humans, or we can deploy it to machines. This means that if we deploy it, if we make the deployment available to humans, we have to have an application that is somehow understandable, or the results have to be understandable. And you have to have like a visualization aspect in there already available as well. And you might have also an application that somehow guides the end user to the results that have been that are available from the analysis that have been performed by the data scientist. And so with this, we can build analytics applications. And here you can see an example of this. So here on top, we have a workflow that has been developed using KNIME Analytics Platform. And some of you might already know that in KNIME Analytics Platform, you can create components. And this is also what Paolo briefly introduced earlier. And components allow you to encapsulate in one node widget nodes and also JavaScript view nodes. And all of these can basically work in an interactive manner and actually build a web portal application or web page, basically with a dashboard that can be visualized on the web directly. And if you build, and if in your workflow there are multiple of these components, actually you can connect them between each other, and you can make sure basically then whenever you deploy this workflow on the server, you can start the execution of the workflow on the server directly from the web portal, and then you will be guided by the analysis that have been performed, and you will be looking at each web page that has been created by basically the components that have been applied or like developed in the workflow earlier. So this is one option, deployment to humans, and then we have another options, which is deployment to machines. And here, generally, we imply that we set up a web service ecosystem where we let KNIME server, in this case, communicate with other systems available in the organization. So we use RESTful web services to set this communication between different services. And then we have also another aspect related to the deployment phase that basically implies the management of the application, or of the application that you have just deployed. So one of these aspects is related to the model factory that Paolo mentioned as well. And in this case, for example, you might have like the goal to retrain a model once the model itself is not performing as expected anymore. So you can take into consideration a certain threshold, and whenever the model starts performing not as expected anymore, so it goes down this quality threshold level that you set before, the KNIME will trigger the execution of the workflow that actually will be responsible to train again the model. And then once you reach the step or like the point where you have the model that is already performing well with new data that have been used to train that model, you can actually then save the model and then use it in the production environment or in the production workflow. So this is all around model factory, so you can handle the automation of the model initialization. You can also monitor the performance of the model over time, and you can also set some alerts or alerting. And then there are also certain aspects related to the management of the server or the applications that you are deploying that are related more on the versioning. So you can handle the versions of the workflows that you actually have deployed to the server. We always ensure also backward compatibility, which means that if you are using a workflow that has been created 2 years ago in KNIME, this will be still working on newer version of KNIME. So we always ensure backward compatibility in this case. And of course, around management, it is also important the documentation. And in KNIME, since it has this graphical user interface, you can also ensure to document each step of the analysis and making sure that the data analyst, data scientist, but even the end users understand each and every single step of the analysis that have been performed. And this goes around also compliance and different best practices that the organization can set up in order to comply with all the different rules around deployment applications. Okay, and so around consumption and optimization, here we are also with another example related to how to deploy your application. And this goes back basically to what we have seen at the beginning of this slide deck. So the deployment to humans or to applications via RESTful web services. But I don't want to spend more time on. We can quickly go through the workflows that we have here. So let me quickly show you the organization of the group 3 deployment. Here we have set two workflows actually that belong to one group, and those are related to how to call a workflow from within another workflow in KNIME Analytics platform. And this allows you to basically use RESTful web services to trigger the execution of another workflow to then get the results back from the first workflow that you are using to trigger the execution. Then we have another workflow related to how to create composite views in KNIME. And we have also a workflow that shows you how to use GET request in KNIME. And there are dedicated nodes for that. And we are gonna go through that. And then we have also another workflow that will show us how to write a specific table to a database. Okay. So let's start maybe with the first exercise here, which relates to predict results using REST API. I'm not entirely sure if this question comes from the group 3, and yes, probably yes. Are multiple model formats supported, like PMML? Yes, yes. So we have PMML support in KNIME Analytics platform, so you can actually save your model as PMML with a PMML format, and then recall the model again in another workflow with a PMML format. Okay, and then we have another question here. Is it possible to do online learning, make incremental updates to a model with small batches of new data without retraining the whole model? Well, I guess you will need, I mean, if this aspect relates to training machine learning models, I guess you will need to retrain the entire model with the new data. And so this means that you will have to reconsider basically the entire set with the new data coming in. Okay, so Paolo already showed you how the workbench works, and how basically how the different windows that we have available in KNIME actually can come in handy here. So we have the node repository, the workflow coach, and here we have the KNIME Explorer. I've just opened here the deployment model workflow, and we can actually go through the different instructions that we have for this workflow and start actually building our workflow. And the idea of, and the goal, as I said, for this workflow is to create a model deployment workflow, and then we'll use these, we will use a workflow to actually call, to trigger the execution of the workflow that we will build here. So the workflow already starts with a couple of nodes available. So one is the table reader node, which is an optional input for the container input table. And the container input table, you see here, we have a table that will be used to make a prediction. But before using this table here, we have to actually use a model reader node to actually read the best model.model file from disk. So we can just start searching in the node repository for model reader. And then we can just drag and drop this node here. And you see here that now the node needs to be configured. And we can double click and then actually go and search and browse for the input location. Another option is to actually go directly into the data folder and then look for the group 3. And then once we reach here, the best model.model, which is actually the file that we have to read in our workflow, we can right click on this, copy the location, and then open the open the configuration file of the model reader node and type in the path that we just copied. So we click OK, and now you see that the node can be executed. It has been configured, and then we have this yellow traffic light here. So we can right click and execute the node, and you see now here it's green. So we just read the model configuration. Now we can proceed with predicting the departure delay for the data coming from the container input table. So this one here that we have at the bottom with a random forest predictor node. So we can use the random forest predictor node here. We can search for it. and then we just drag and drop it here in the canvas. And then what we need to do here is to connect the model reader output node here with the input port of the random forest predictor node, and then we take the output port of the container input table and then connect it with the input port available with the random forest predictor. Now you see it's somehow already configured this node. We don't have to actually do change any settings, so we can just leave it as it is and then execute the node. And then if we are going to check the output, you see here that we have again all the input features that we have used to train to actually make the prediction. And then here at the end of the table, we can actually check the prediction that have been performed by the model and also the confidence basically related to that prediction. Okay, so now we see that the prediction is no delay for this set of data. And the next step is to convert the predicted data into a JSON format. So what we want to do is now to really convert again everything that we have available here in the random forest predictor output node, and then use a container output node, and then just connect it with a random forest predictor output port. And then even in this case, we can just execute the node. And then you'll see here we have basically the same table that will be used actually to basically send back the results of the execution of this workflow to the workflow that actually triggered the execution of the workflow that we just built. So we can even reset the entire workflow, save it, and then we go to the next one here, the call workflow node, which will be the one that actually will trigger the execution of the workflow that we just built. So I'll just go through the questions if there are any here before to continue. Yes, does retraining consist in updating also parameters of our model? Yes, so basically once you retrain the model, then this means that also the parameters of the models that you are retraining will be somehow retweaked again to make sure that the model performs again like as expected for the new data. Okay, so as I said, for this second workflow, the idea is to apply model to some deployment data by calling the workflow from our local system or from KNIME server. So the idea then is to read the data optional underscore deployment.table available in data/1 underscore input / group 3. So we just take this node here. We just drag and drop actually the table node into our canvas. And you see here we have already our input location already filled out. And then we can execute the node and then inspect the output table. And you see here we have our table with all the different features available in there. And then what we can do next is really to use the call workflow table based node and that will be used basically to call the execution of the workflow that we have built before. So in this case, we can just, I was just checking if there are other questions here. Is the process for deploying an ensemble of models the same? Yes. So basically, you will need in this case to create your ensemble model, or exactly create your ensemble model, and then basically you will be able to save the model with this with the model format that we just saw. So there is a model writer node that we didn't use because we already had our model available in our KNIME Explorer. And once you have your model written in a certain location, you can actually read it again from another workflow. So yeah, the process is exactly the same. Okay, so we have now our table reader, and we're going to use the call workflow table base node. This one, and just connect the output port of the table reader directly with the call workflow table base node. And now we can actually open the configuration of this node. And you see here the idea of this node, I mean, the usage of it, the purpose of this node is to trigger the execution of another workflow that we have available in this case in our KNIME Explorer, but we can also connect potentially to KNIME Server and then directly trigger the execution of the workflow available on the server. So we can browse here the workflows that we have available, and you see here you'll see the list of all the workflows that I have available currently on the workspace that I'm actually using. And the workflow that we need to execute is the group 3. Actually, this is available under, we can just go through that events, and then basically the idea is to okay, deployment is this one. Exactly. So the idea is to really execute the workflow that I just highlighted here. And then I can just click OK. And now the node is now configured. And then I can just execute it. And actually something that we can check here on the KNIME Explorer, maybe I can just reset it and I can show you again. If you check here the list of the workflows that we have also the group 3 underscore call underscore workflow, which is the workflow that we need to execute, starting from the one that we are just building right now. So if I right click on the call workflow table based node, and you check here in the meantime the local workspace and the workflow that we need to execute, you see that it's pretty fast, but it shows also now an icon that basically tells us that the workflow has been executed. And now I can check the output, and you see that now I have my table and also with a prediction, right? So we can also check that again with this visualization maybe. So it gives you an idea on how this can how the call workflow table based node can trigger the execution of the other workflows. I can just reset it, this again, and then I will just execute it, and you see that automatically the group 3 deployment model workflow will execute. Okay. So then we can just use the JSON to table node to actually convert. if we would have had, let's say, this doesn't work like that, but if we would have had like um, a node that would output a JSON format for the execution of the call workflow node, we would also automatically add to use a JSON to table node to actually convert the JSON format into a table. Okay, so the same thing actually, as I mentioned before, we can do it by triggering the execution of a workflow directly available on the server. So I'm now connected to the server that we are using for this event, for the Learnathon event. And I have here also the solutions. So let's say I want to trigger the execution of this node that we just built and that is available also in the solutions. So I can just use the KNIME server node, which will allow us to connect directly to the server. And here I can input the address basically of the server, which I will quickly take it from here. And then I can input my username and password. I can either test the connection or just execute the node. And then I can connect the KNIME server connection output port directly with a call workflow table based node. Okay, so now I can even browse my workflows here that are available on the server. And you see here we have also our solutions, and we can actually trigger the execution of the workflow that we have available here, the group 3 underscore deployment model. Okay, so let's just look for it. Here we are, select, and then we click OK, and then we can just execute the node. And this will use basically RESTful web services to just trigger the execution of the workflow and then retrieve the results back directly from the server. And you see here, since we have used RESTful web services, now we have a JSON format that we can now convert into a table. And that's where the JSON to table node comes in handy in this case. So we just connect the call workflow table-based node with the JSON to table node. And then here we have a number of settings to basically understand basically, or like set how the arrays should be kept. And we'll keep for now the default settings, and then we'll just execute a node. And then if we check the output table, you see that now we have again the table readable directly from KNIME. Okay. So we have another question here related to, let me just read it out loud. After a model has been deployed, how would you update the model with new data? Okay, so this is part of the, let's say, model factory that we have built as a blueprint, and it's also available like the workflows are also available on the hub, and you'll find also the white paper related to that. Maybe we can follow up on that later, since it's a really broader topic and needs to be discussed in detail. Okay, do you have any question related to what we just saw? Okay, so if not, we can actually go ahead and move to the second workflow that we have here, which is the composite view. And maybe I'm not entirely sure if we will have time to go through all the workflows here. So maybe we can just focus on this one for now. And then we can take a look maybe at the solutions for the other workflows. Let's see how much time we will have until the end. So for the composite view. So as I said, this is one of the options that we have available in KNIME to be able to, let's say, enable the collaboration between a data scientist or data analyst and the end user, which is going to be responsible basically to take business decisions out of the analysis that have been performed earlier. And the idea is really to create a dashboard and that will be available then on the web portal once we deploy the workflow to KNIME server. And Paulo quickly showed you how to do that, but we can actually start building the composite view from scratch here. And then if you have questions, we can quickly go through that. Okay, so what we are going to do now is basically to read the start reading the deployment.table and the random forest model best model.model available in the same folder as before. So we just drag and drop deployment.table in this case. Configuration settings are pretty easy here. We just have to execute the table reader node, and then we will be able to read the entire table here with 3,000 rows. And you see we have all the different features. So you can go through that and check the output table. And then we're going to read also the best model.model. In this case, we need to use the model reader node. We can actually search for it directly in the node repository, drag and drop directly in the canvas, and then copy the location, go in the input location field, type in there the location of the model file, and then execute a node. So now we have our first new nodes available in the canvas, which have been executed already. So we can go forward and actually apply the random forest node here, predictor. So this allows us basically to make a prediction using the random forest. And then we basically just link the model reader or like connect the model reader with the random forest predictor node, and the output port of the table reader will go here at the bottom of the input port of the random forest predictor node. Now everything is just ready as we did before, so we don't need to change any settings. We can just execute the node and inspect the results. And you'll see here that if I go at the far right of the table, we see the predictions that have been performed for each and every single row of my table, initial table, and then also we have here the values related to the confidence. So we have these values available for all the different rows. Okay, so we can now actually, so if we want to build a visualization, we can actually focus, for example, on renaming certain columns, for example, or to resort also the columns that we have available in our output table. Or we can just go through directly the visualization aspect in this case, just to take a look at how that would look like. So we can use the interactive range slider filter widget node to actually create a range slider to select the day of the month in the composite view. So we can just search for the node here available on the node repository. We can drag and drop it on our canvas and then connect it with the random forest output port. Okay, so the idea now is to, as we said, you select the day of the month. So we can just go through here and then search the day of the month. And here you see we have already some data that have been automatically filled and that are available as ranges. And we have here other options that are available in other tabs, like how the slider should behave, if we should use any stepping, and if we should use the slider to define the maximum or the minimum or both the values. And we can also decide how to have the orientation of the slider in our dashboard, in our final visualization, and also the direction if we want to have the data looking at from left to right or right to left. Okay, so then we have also some labels here that we can set. We will for now keep everything as per default, and we'll just execute the node. Okay, the nice thing about all the widget nodes and also the JavaScript view nodes is that we can inspect the interactive view of each one of those outputs. So if we do that for the slider, you see that now it's loading, and then we see here basically that this corresponds to the day of the month. Of course, here we might need to change the decimals. So, and we want to actually go through like each day, so we can actually change the configuration of the slider. And we don't want actually decimals in this case, and the step size should be 1. So if we re-execute the node and we look at the interactive view, okay, you see now that we can go through each day of the month. Okay, so now what we can do is to actually use a table view to being able to visualize the table on our dashboard. Okay, which is another JavaScript view node. So we can just connect it with the interactive range slider filter widget node. This means that whenever on the web portal, whenever I will select a certain range from the interactive range slider filter, this will also affect the visualization of the table, basically, of the data that I'm visualizing here on the table. And now what we're going to do is to use, so we're going to check again the suggested steps. We're going to use the color manager and then the scatter plot to actually visualize the scatter plot and color the flights according to their departure delay status. So first use the color manager. We drag and drop it to the canvas. We connect it with the interactive range slider filter widget node, and then we can actually change, for example, the colors for delay and put them blue, and then execute the node, and then we can use the scatterplot JavaScript view node and connect it directly with the color manager. And in this case, the idea is to visualize the airtime and the air delay. Okay, and the air delay, arrival delay, sorry. Okay, so now we have chosen the columns for the x-axis and also for the y-axis. And here we have, as you see, we have other tabs that are available for this JavaScript view node for the scatter plot. And we can also label the we can label the x-axis as well as the y-axis. We can, if we have dates or time available in our axis, we can also set we can also format those data, and we have other options related to the general plot, like we can set the title and also subtitle, and we can also show the color legend. In this case, it's automatically selected, or show the grid. We can also, every JavaScript view node actually outputs an image. So you can also decide to export an image in SVG format. So you can set here the sizing for the image. Okay, so now we can just execute a node. The warning message tells me that I'm only visualizing the first 2,500 node. I can change this option directly in the first tab here by just increasing the number of rows that I want to visualize. Okay, so now what I can do is basically to encapsulate everything in one component. So select all the nodes that I have available and then rename the component into view. I basically go inside of the component. I can do that with a control button and then double click with a mouse. To give an order basically to the execution of the workflow, I can just connect the input port of the component with these flow variables. We call them flow variables. And then basically here, what we need to have in output is an image, for example. So we can set up the output port for the component, and then have the image in output. Okay, we click finish, and then we have to go again within the component, and then just connect the scatterplot output port image with a component output port. Okay. Now everything is ready to be executed. I'll show you the interactive view here. And this will bring again to the topic that Paolo introduced before at the beginning, basically, of the presentation. We have here different components, let's say, or different outputs available in our page, right? So, and by default, KNIME creates its own layout. So we have the slider here at the top, then we have the table, and then we have the scatter plot. We can actually change this layout by going into the component, then click this dialog available here on top of the toolbar, and then we can actually change this by, for example, with a drag and drop criteria. We can just do this and then maybe put the table on the left side, and then move the scatter plot on the right side, and we can remove basically the other boxes here. Okay, so if we now click finish and we re-execute and open the view of the node, you see that we have now the table on the left side and the scatter plot on the right side, and on top the slider. So the nice thing is that all these components can actually interact between each other. So once I, for example, filter some data in the slider and I move them, you see that the data visualized both in the table and in the scatter plot will change. I can also do some selection here in the scatter plot, and this data will be automatically selected also in the table that I'm actually visualizing. etc., etc. So the nice thing is really that I can create components and have interactive visualization, so the end user can really take a look at the results that have been performed, analysis that have been performed. Okay, so do you have any question related to components and composite views? Okay, so if not, I will quickly go through the other workflows. Maybe we can just take a look at the result, at the solutions. Since I think we have only 10 minutes left. So another option actually to deploy basically your results is by creating a report using BERT. BERT is a tool, an open source tool that is actually integrated with KNIME, and it's available, it's embedded basically within the KNIME installation. And this workflow in particular shows how to create a pretty simple report using BERT. The nice thing about BERT is that it has it looks like creating like a report, or like it has functionality more or less as you were using Excel, for example. So it's somehow intuitive, although at the beginning it might take some time to understand like the overall concept. But I think it's a really useful integration to be able to create report in KNIME. So in this case, what we do basically is to read again a data set. It's basically the same data set that we have seen before, with information related to air carrier, the arrival delay, etc., etc. All the data have been normalized here. We have the date, and we have the information related to departure delay, etc., etc. And then we can again read the model. Same concept as before. We use the random forest predictor node to predict whether the flight will be the prediction. The departure will be delayed or not. And then we can actually. This is just an example. We can, for example, from our output table, we can filter our data based on the destination. So maybe we can focus mainly on the destinations of Austin Airport, for example. So this is what it does, the row filter node. It just filters data based on Austin. And then we execute this, and you'll see that now the data set has only 21 rows. So we can now move forward. We can use the bar chart to actually visualize the departure delay. We can use the departure delay as a category column, and then do basically the occurrence count based on this variable. And if I execute and open the view for the bar chart, I see here the output. Okay, and then if I mouse over, I can actually see also the occurrence count for each one of those values. And then with the data to report node and the image to report node, we can actually export the data and send them directly to BERT. When we use these nodes, when we send data to BERT, we have to make sure that whenever we use data to report and image to report, we change also the annotation for the node. So we have to make sure that we identify basically what we are exporting and what we are making available to BERT. So in this case, for the data to report, we are exporting flight data, and for the image, we actually exporting the delay plot, delay plot. So if we actually execute these nodes as well, and we click on this button available here on the toolbar, this opens the report associated to this particular workflow that we have built. We just save it now, and the table has been already created. So the idea is that we show here some flight statistics. We have the dataset view here with all the different variables that we imported from the table, and then we can, if we actually drag and drop this item, this dataset, to the report here, to the editor of the report, we can actually select the columns, the variables that we want to add to the report. And this is what we have done here. So automatically, once we select the different variables, automatically the table will be created. We added here a text that basically refers to the flight statistics. And then we have added also an image, which is not visible here when we create the report, but once we run the report, and we actually can do that by creating different reports available in different formats, we can actually view also the report with a web view. Let me see, which is now loading. I'm just showing you here. And you see here that we have our title, we have the data available to referring to the data set that we exported, and then we have the image related to the plot that we exported as well. So this is a report available on the web, but please be aware that we can, for example, view the report as PDF. We can, so this will automatically save the PDF on your machine. We can also visualize as PowerPoint, etc., etc. Okay. I see here one question related to the composite view that we saw before. If it is possible to hand over this to a user without giving the user the entire workflow. Yes, so I actually didn't demo that, but I can quickly show you. I'm now connected to the web portal. Basically, I'm just using a web browser here. And you see here that I have visibility on the workflows that that have been deployed directly to the server, and for which I can basically for which I have access rights to visualize and execute through the server and through the web portal. And this this workflow here, the group 3_composite_view, is actually the workflow that we have built before, and I deployed it earlier to the server by a KNIME Analytics platform. So now this workflow is also visible and available on the web portal. So if I just click on this workflow, I can start the execution of this workflow on the web portal. And imagine once I actually log into the web portal, I can give access to the web portal basically to the end user, so they can inspect and run the workflow basically on their own without actually taking a look at the what has been built basically in KNIME Analytics platform. So they just have visibility on what is available on the web portal. So all the complexity is hidden in this case. Okay, so I hope, because I've seen a comment related that you were not able to visualize the web portal. I'm not sure if you were able to see that.
Yeah, we see it. We were seeing the KNIME program, but now we see the web portal, the
Okay.
web page. Yeah,
Nice.
all fine.
Cool.
Thank you.
Yeah. So basically, from the web portal, again, I have the same type of interactivity, so I can use the range slider filter definition to basically filtered data available on the scatter plot. I can do a selection here again on the scatter plot, or also some selection here on the table, and this will automatically highlight also the dots that I have available on the plot. Okay, here we are. So just moved back to KNIME Analytics platform again, and we have here a couple more workflows. Maybe I can quickly show you the GET request node, the GET request workflow. The idea here is to use RESTful web services to interact with a service available on the web. So in this case, basically the GET request node allows us to access air quality information, and the configuration of this node is pretty easy to set up. So in this case, I just have to input the URL, and if I need to authenticate against the service, I have here different options. There are also other options available to request headers and response headers. But let's focus for a second on this URL for now, and then execute the node. And you see that now I have the response, the status is 200. So it was a successful request. And I have here a bunch of information that I just retrieved from the service. And I can use the JSON to table node to actually visualize the results on with a KNIME table format, let's say. So those are all the values available. So for a specific location, I have other information related to latitude and longitude, for example, and also the source name, AirNow, and the ppm unit and the value. And the last workflow that I wanted to show is related to the write table to database. The idea here is really to show how we can basically how we can write the results of our analysis into a database. So we start always with the same concept of reading some data coming from certain service, or maybe in this case from a specific table. And then we read also the model that has been previously trained. We apply the model with a predictor, and then we get here some results, right? Now, I can either write the results into a table again. So I just need here to write the output location, and then the table will be available in that location. I can use also Excel writer nodes. I can use CSV writer nodes, etc., etc. And then another option is to actually write the results directly into a database. So first of all, I would need to connect to a database, and then I can use the DB writer node to actually create a table related to the predictions that I performed earlier with the predictor node. So to connect, in this case, we are using a file-based database node, which is SQLite. I can actually create the file database on a dedicated location that I specify here. With all the database connector, I have always to specify the database dialect and the driver name. In this case, those are pre-configured because it's a dedicated node to connect to SQLite database. And then I have a bunch of more settings here related to JDBC parameters or advanced options related to the connection or the dialect syntax, etc., etc. And I can actually potentially use database, for example, like Oracle database or MySQL. I see here question related to if I can write prediction to a graph database. The answer is yes. We have also integration with graph databases, and actually a partner of ours developed those and are available within the extensions from partners. Maybe I can send you the link later. Okay, so yeah, we probably have to step out now. I think we have to go back to the other to the main session probably as well, since we are getting closer to the end. But let me quickly show you the database writer node, which allows you to create a table from the existing database. So in this case, I can write here the schema which I want to refer to, and also the table. In this case, predictions is the name of the table that I'm creating now. And here I can basically include or exclude a number of columns that are available from the input table. Once I click OK, I can just execute the node, and now I have basically my data available in my data set. And the nice thing is that with a DB writer node, I can also visualize basically what I've loaded into the database. So I can cache a number of rows. In this case, the default setting is 100 rows. So I'm able to visualize the first 100 rows. And here I can also visualize the query that has been performed in this case. Okay. So yeah, we quickly went through a number of options to actually handle the deployment phase in KNIME. We didn't have too much time actually to go through the different features available with KNIME Server, like how to collaborate, how to make sure I can share my workflow with my colleagues, how to handle the access rights, for example, or how to also automate the execution of a workflow on KNIME Server. But if you are interested in that, maybe we can send you a couple of links to webinars that we have run around KNIME Server, and also we have also an e-learning course for KNIME Server that actually walks you through all these different steps and functionality available with KNIME Server.